Unfortunately, some people don't know who I am. So I made a website, ben.enterprises. On this website, you can see my name is Ben Friedel. I'm studying comp sci and info sci at UW-Madison. Some prior experience, blah, blah, blah. If you scroll down to the bottom, you'll see that I've got a list of blog articles. Now, in order to make the browser show a list of blog articles, I've got to have HTML that looks something like this. You'll notice that this HTML follows a pattern where we put the article path and the article title into this HTML formulation. And it's kind of a pain to type all this by hand. So it turns out there's a really cool tool to automate this. It's called a for loop. So as you can see, simple for loop over the articles, and I can easily make those links. But I'm not the only one who has a blog. Before me, there was Netflix. And if you go to the obvious domain, netflixtechblog.com, you'll see that they also have a blog. And as you scroll down, you'll notice they also have a list of blog articles. Their list is a little more fancy. As you continue to scroll down, it'll continue to load more and more articles. And so, but fundamentally, this is still just a little bit harder of a string templating problem. They have an article image, some extra metadata, but it's still a similar problem. So how did Netflix's blog solve this problem? The answer, over 2 novels worth of JavaScript. Seriously, the entire text of Pride and Prejudice compressed is 220 kilobytes, and the amount of JavaScript on this page is over double that. And this causes real issues. This JavaScript on an older phone can take almost over 2.5 seconds to execute. And studies show that ain't nobody got time for that. And then if you want to actually read one of these articles, you get hit with another 4 novels. So how do we get here? So Netflix, right? They haven't made that many websites. So they outsourced to this company called Medium. And Medium's entire business is hosting blogs. And so Medium goes, right, hey, we're this hip, trendy startup. We should use hip, trendy tools. So they grab React, Remix, everything but the kitchen sink. They throw it all in a blender, and they hope their website's golden. And this is software alchemy. All right, they're just grabbing shiny tools, they're throwing them together, and they're hoping the result is golden. And so why does this not work? Well, because oftentimes these things that you grab, they're designed for different use cases. And something being popular doesn't really say that much about how well it solves your problem. And so here's a few case studies in how this goes wrong. First example is the undergraduate project lab. They had some servers for running student projects. And so what they wanted to do is they had a small number of servers to run student projects in a semi-isolated manner. Some downtime would be okay. It's not the end of the world. But they want things to be somewhat reliable. And crucial is that it should be simple to maintain, because students graduate roughly every 4 years. So there's a constant churn of people who are maintaining the servers. And so to solve this problem, they turned to Kubernetes. Now, Kubernetes is designed for large organizations. Even Google thinks it's incredibly complicated, and they made it. And one of the things it does is it attempts to detect and work around broken servers. And normally, this is great. But when people don't maintain the cluster for a while, what happens is all of the servers think all of the other servers are broken. And people tried to fix this. Many people tried to fix this. But ultimately, none of them were able to fix it. And another example of how things go wrong is log4j2. So a lot of times when people are writing Java programs, they want a logging library, and they want it to write some text to standard output, but they also want to write to disk. They want to have different logging levels, warnings, errors, info, and they want to be able to filter based on those. They generally want configuration to be simple. No one wants things to be complicated. And they don't want it to slow down their program. Blocking the main thread to write logs to a file and standard output. No one wants that. And so to solve this, they turn to log4j2 sometimes. And so why was log4j2 made? Well, they'll tell you in this blog post they wrote. And if we take a look, they made it for logging things that aren't text. A newer version of the syslog binary logging protocol, a bunch of plugins, a bunch of different features, and performance. But the performance of log4j2 in the modern era is really not even that great. And combine that with a complicated XML config and a bunch of features that you don't really need, why are people using this library? Well, one reason is that it's popular. Netflix uses it. If you find some random blog post, they'll probably tell you to use it. And it has all these features, and even if you don't need them, they can't hurt, right? So Log4j 2 had a vulnerability because it supported logging Java objects from arbitrary web servers when you printed a special string. And this is a bad idea. And even worse, it used Java serialization, which allows running arbitrary code. So if an attacker just tricks you into logging a specific string, they could run whatever code they wanted on your web server. And nobody wants this. So what can we do instead? Well, software engineers, their whole purpose is to solve problems with software. And there's a really great tool for solving problems, the engineering design process. So here's my take on the engineering design process. The first thing you want to do is you want to understand your problem. What are you trying to solve? You want to consider what the inputs and the outputs to your program are, because ultimately, all software is transforming inputs into outputs. You want to consider the volume of these outputs. Are you designing something for 10 users or 10 million users? These programs will look very different from each other. What constraints do you have? You probably have limited time. How much time do you have to make the solution? You probably have limited money. And there's probably legal and ethical concerns. And then, so once you understand the problem, you can move on to planning. So you got to make a preliminary plan, for transforming these inputs into the outputs. And you should look at existing solutions to similar problems. And you should consider if it's worth reusing them or their ideas in part or in whole. And you should consider, should you break into the subproblems? Can you break into the subproblems to make your problem solving easier? You should consider what hardware you're using. What hardware are you using? And where is the hardware? Is it in a data center in the cloud? Is it a phone in the user's hand in the middle of the desert? Where is the hardware? And what is the hardware capable of? I'm not saying you need to memorize the L3 cache latency, but it certainly wouldn't hurt. And then once you have a plan, you can move on to creating the solution. So you should implement your plan. And sometimes when you implement your plan, you run into difficulty and you gain new insight. And then you can go back and revise your plan with this new insight you've gained. And then once you've created your solution, you have to move on to actually using the solution to solve your problem. And sometimes there's simple problems with your solution. There's just simple bugs that you can just go fix. But sometimes you find that there's more systemic problems in your solution, and you just got to go back to planning again. And sometimes the problem just changes. You gain new constraints, you widen the scope of your problem, or you find out you didn't truly understand the problem to begin with. And so what does good engineering look like? Here's a few case studies. So Shopify, they started with just a simple Ruby on Rails architecture. They had a MySQL database for storing the data, Memcache for caching, and then Redis for queues and background jobs. And this architecture, very simple, but it solved their problems effectively. But eventually, as the company grew, this was no longer enough. And so what they did was, Shopify has all these different stores, so they just created different pods where each pod would manage a subset of the stores. And so they were able to keep their existing backend and just divide up the stores into these different pods. And then they just had an Nginx load balancers that would filter the requests to the correct pod. And so this is very simple. It's not flashy, it's not complicated, but it solved their problems effectively. And eventually, managing all these pods got kind of complicated. So what they did was they used Google Cloud's Kubernetes engine to manage scaling as needed. And while this might not have made sense for a small lab, when you have Google taking care of all the hard work of managing the cluster, and you are a highly profitable business that wants to be able to scale fastly, this makes sense. And so another example is Ahrefs. Ahrefs makes SEO tools used by half of Fortune 500 companies. And so to do this, they've got to scrape and store the entire internet. And this takes a lot of bandwidth and storage. And so what they found was, instead of continuing to use the trendy hip cloud, they started using their own servers in 2017 to lower server costs. And what they found was they saved almost over $1 billion by using their own servers instead of AWS. And so while this wouldn't have been necessarily an obvious solution, it was highly effective in saving them money, and they wouldn't have even been profitable if they had continued using AWS. And so why does software alchemy persist if software engineering is so great? I've thought of 3 reasons. The first is, by just copying others, you can deflect blame. If the popular tool fails, you can just blame the tool. You know, how could I have known? But if you use an unconventional solution, then if it goes wrong, it's your fault because you made, a silly choice. You should have obviously used the popular solution. This is kind of the nobody got fired for buying IBM mindset. Another reason is resume-driven development. People think they use all these fancy tools and they can just put them on their resume and they'll get a better job somewhere down the line. And the final reason is just, maybe people are clueless. They think that just throwing stuff together is somehow going to get them a better result than, using a more thorough process. And I think ultimately these excuses fall flat. Deflecting blame, that's just lame. And, a poor craftsman blames their tools. Resume-driven development, nobody reads your resume, little bro. And if they do read your resume, they're just looking at the company names, maybe the school name, and they're either putting it in an accept or reject pile in like 4 seconds. And cluelessness, don't be clueless. So in conclusion, don't just throw shining things together. Use the engineering design process. Use tools that solve your problem, not tools that solve somebody else's problem or a problem you don't have. And stop making excuses for bad software engineering. Thank you.